is a type of acceleration, it's just negative. Okay. So when we calculate acceleration, take out your formula sheets and let's see if we can find it. Okay, so on your formula sheet, so we've done V equals d over t, we've done V arrow equals d arrow over t, and then right below that, can you see the A? Yeah. A equals v over t. What does the A have over top of it? An arrow, so that means it must be a vector quantity. So you see it says delta V over delta t, and another one of yours, which I want you to write down, it says it on your formula sheet, is VF minus VI over t, right? That's what it says on your formula sheet? Does it use VF, right?
Yeah.
So this is the really important one that we're going to use most of the time. Okay, so when we think A is equal to VF minus VI over T. Now when you're rearranging this formula, you need to make sure the VF and the VI stay together. Okay, so you can't just start to move the VI without first dealing with the time, and I'll show you that in a bit. So acceleration is measured in meters per second squared. Now it tells that to you as well on your formula sheet. If you look over, it says acceleration meters per second squared. Like right across, or a little bit down. Yeah, highlight that. So if you're doing a test and you forget what your units are, it tells you right there on your formula sheet. You get these on your test, so make sure you use that. So yeah, you can highlight that acceleration is meters per second squared. Velocity is measured in meters per second, and time is measured in seconds. So now let's just make a note here. VF, what do you think VF stands for? Velocity forward. VF means final velocity. And VI means, what do you think then? Initial velocity, yeah. So that's why when we're taking the change in velocity, we have to go VF minus VI. So VF is final and VI is initial. Okay. Keep in mind, as you guys have said, acceleration is a vector quantity. You guys have said. So it needs direction included. Now, acceleration will be positive if both magnitude and direction are positive, because we can have a positive times a positive will equal a positive. I get into this a little bit more in detail in Physics 20, but I won't go any further than that for right now. What else is on there? No, lots of those are acceleration ones. The two at the bottom, the EP and the EK, will do those ones. Okay, so both the magnitude and direction are both the magnitude and direction are, so if they're both negative, we'll also end up with a positive acceleration. So if you have a negative times a negative, you'll get a positive. So it's like if I'm decelerating to the west, I end up with a positive acceleration. So if you're decelerating, your acceleration, like your magnitude would be a negative, but if you're going in the negative direction, then you end up having a positive. Again, I'll do that way more in Physics 20. Don't worry too much about that right now. Okay. Acceleration will be negative if either the magnitude or direction are negative while the other is positive, because a positive times by a negative will give you a negative. Okay. So again, yeah, we'll just, I'll give you some examples about that, but we do that a little bit more in Physics 20. So, did I give you the graphs? No? There's no graphs. Okay. So, when we've been dealing with acceleration, you guys had started to talk a little bit about acceleration. So if we looked at acceleration on a graph that was, say, like this, so we have our graph, and say we have v on this side with an arrow, velocity, and we have time on our x-axis. And what if our data gave us a graph that looked like that? What would we say about the velocity? There is what? What's happening with the velocity? Is it changing? Or is it staying the same?
Uniform motion.
It's uniform motion. It's constant. Yeah, so we can say there is no change in velocity. It's staying the same. Right? So uniform motion. So then, is this object accelerating? Is it changing in velocity? No. And our definition said acceleration is any change in velocity. Yeah, and there's no change in velocity, right? So, yes, that's right. So acceleration is 0 for this type of graph when it looks like that. Okay? So let's try another one. Say we have a graph. Again, let's do a VT graph. What if this time a VT graph is increasing like that? What's happening to my velocity of my object?
It is increasing.
It is increasing, yes. And it's changing in a positive direction. And as Josh said, it is increasing. So it's going up in the positive direction, above the x-axis. So then what's happening to my acceleration? Is this object accelerating? Is it not? What can I say?
It's accelerating.
It is accelerating, yes. So, and I will say that it is positive acceleration. Okay. Now, the last one that we will look at, let's say, again, we have a VT graph, but this time, it goes like that.
Deceleration.
How do you know that?
It's going down.
It's going down, so it's decreasing.
So is one of them negative and the other positive? Would it be in a negative direction or decreasing direction?
Well,
Or are they both the same?
it's decreasing. We don't really know what direction it's going.
Well, it's going. If it's going down, then it'd be going southeast.
Well, not necessarily. We should say this is a decreasing magnitude. We don't know actually about direction because because the actual vector isn't showing you what direction it's going, because the graph could have said like that this is going east. Now the only time, and this is getting into physics 20, but the only time that it's changing direction is if it went past the x-axis. Once it goes past the x-axis, then it would be going west. But right now, it's still going east, but it's slowing down, right? Because if I look here, say my velocity is like 5 meters per second, but then here it would be like 1, and I'm slowing down, right? So this object is slowing down in the positive direction. It's still staying the same direction, it's just slowing down. So we would say acceleration then is negative because it's slowing down in positive direction.
So could it be slowing down in a negative direction?
Yes, and then if it's slowing down in a negative direction, then it would be a positive acceleration. But again, you don't have to really know that in detail. So it's just to get this concept in our mind of velocity and acceleration. Okay, so now, okay, ready, set, go. No, I shouldn't do it yet. No, I won't do it. Your minds will blow up. Okay, so I'll tell you about it tomorrow. It'll be fun. Okay, so acceleration can either be calculated mathematically it's a long word with a formula. So our formula is A equals VF minus VI over T. Or by using a graph. You can find the slope of a VT graph. But that's for tomorrow.
So the slope is the acceleration.
Yeah, because watch this. You want to see it? Okay, I'll show you. No?
Yeah.
No.
Can't tell, it's not certain.
Is it too much? Okay, you don't have to write it down. But okay, so if I have a VT graph, the slope is rise over run, right? So slope is V over T, right?
Yeah.
If for this graph. A is equal to V over T. So if I find slope, see, look at that.
Finding acceleration.
I'm finding acceleration.
I thought you were finding the
Mod displacement.
That's for a DT graph. Or what do you mean for, oh no, if you find the area of a VT graph. So V times T, that's V. So that's area.
But you never actually, I get it.
That's what we did before. Okay. I'm going to give you a sheet that has all the summary information about graphing on it tomorrow. Okay? All right. Okay, so but first today we're going to do the mathematical one. We're just doing the math part today. Tomorrow we'll do the graphing. Okay? Or if we're fast, we'll start the graphing today. Okay, so an example. A racing car accelerates from rest to a speed of 200 kilometers per hour. Ooh, and it gave us the conversion. That's nice. And 55.6 meters per second east in 6 seconds. What is the acceleration of the car? So, to do these questions, please listen. Look at me in the eyes. I want to look at all of you. Look at me in the eyes. The first step is always to write out what you know. The first step is to
Write out what you know.
thank you, Jeff. Now everybody, and you ladies. The first step is to come on back row. The first step is to I'm not going to move on until Chris says it. The first step is to okay, he he kind of mumbled, sort of. Right on. Okay. So let's write out what we know. Look at, here it says from rest. That means my initial velocity is 0 meters per second because I was resting. So that's initially I was at rest. 0. Then I'm told it accelerates to a speed of this. And I'm going to use the meters per second one because my time is in seconds. That's easier. So that is VF is equal
Do
to...
they have to have arrows over the V's?
Yes, thank you, Josh. Now,
have to be lowercase.
this?
Yeah.
Yeah. It's like the V, and then there's a little subscript, it's called. That's called a subscript when you, it's like, should be little. Okay? Now, it says 55.6 meters per second east. So how do we translate east? What is it? Positive. So we need to make sure that's positive. Okay? What else do I know? In 6 seconds, the last time I checked, that is a time. So T is 6.00 seconds. And then you write out what do you want to find. So that's step 2, writing out what you want to find, which is A, acceleration. So now you make your formula that will put them all together. So A is equal to VF minus VI divided by T. Now, if, no, I won't tell you that yet. Okay, so now we just plug in what we put over there. So VF is 55.6 meters per second, and it's a positive, minus 0. It's kind of redundant to write it in, but we'll just write it in for now. Divided by 6.0 seconds. Hi.
9.26 meters per second squared.
9.2666 meters per second squared. Now we will write in our final answer. This is not final yet. So, we need to have sig digs. So how many sig digs do I have in my question? 3. Very good. So 9.2
7.
y.
Because there's a 6 after the 6.
Very good. Meters per second squared. Convert the positive into a direction.
East.
East. That's our final answer.